Hello everybody, today's video is going to be covering tangents of circles. There's a few quick vocab words we need to cover and then we're going to jump right into our examples. The first vocab word, which you have seen before, is a tangent, and this is a segment, a line, or a ray that touches a circle only one time. And I've gone ahead and drawn that in for you. Most of the time when we draw segments, they're going to be considered lines, but again, they can stop or be going in one direction. The other vocab word we need to know is what we call the point of tangency, and this is just the point where the tangent line hits the circle. Okay, and what's unique about tangents is that they are always going to be perpendicular to a radius or a diameter. And remember, perpendicular means that they form a right angle. So I'll write that here. Form a right angle. So if I draw the radius in here to my circle, then I'm going to automatically have a right angle here. And this is going to be very helpful because we can create right triangles from this, or we can find other different measures because we have the right angle there. All right, so let's look at our first example. It says, is LM tangent to the circle? And show your work to support your answer. So the easiest way to be able to tell this is to remember that we know a tangent forms a right angle. So what we need to do is figure out if these given measurements would create a right triangle using Pythagorean theorem. So remember, a squared plus b squared equals c squared. So what we're going to do is fill in what we know and then plug into our formula. So if this is where our right angle should be, that means that this whole length here from R to L is our hypotenuse. And then we have an A and a B. So that's our A squared, B squared, and C squared. Now, A does not have any number there, but remember, in a circle, a radius is the same no matter where you draw it. So we know from R to K is 12. That's what I'm highlighting in green here, which means that R to M also has to be 12. And so even though they didn't give us that measurement, we can fill that in because we know it's a radius. And now we just plug in what we know. A, we just said, was 12, so 12 squared. B, we just said, is 16, so 16 squared. And we want to know, does it equal 12 plus 8 squared? So 12 plus 8 is 20, so 20 squared. And make sure you're using the entire hypotenuse, not just a piece of the hypotenuse. Now we can go ahead and start doing our calculations. So we know that 12 squared is 144, 16 squared is 256, and then when we square 20, we get 400. So now I just need to know if it works. So 144 plus 256, that does get us 400. And since the same number is on both sides of the equation, it is a tangent. So we'd say, yes, it is a tangent. And we're done. Okay. So when I say show your support or your work to support your answer, that means show me the calculations you use to prove it. Don't just put yes or no. You have to have some calculation to support your answer. Okay. The next example is same concept, except this time we're going to be using the fact that it is a tangent to find a missing length. So here we would be told that GL is a tangent. Okay, you have to know that first. And we want to find that missing length of GL, so where the X is. So let's go ahead and fill in what we know. We know that the radius is 1.5, which means that HG also has to be 1.5. And we know if it's a tangent, we're going to have a right triangle. And so now we can go ahead and fill into Pythagorean theorem. So we've got our two leg lengths, so 1.5 squared plus x squared has to equal our hypotenuse squared. And our hypotenuse, when I add those two things together, is 2.5. So 2.5 squared. And now we just go ahead and start solving. 1.5 squared is 2.25, so 2 1/4 plus x squared equals, and when we square 2 1/2, we get 6.25. Now we can start solving. Subtract 2 and 2.25 over to the other side, and we get x squared equals 4. And then to get rid of a square, we square root both sides, and we get that x is equal to +2. So our tangent, or GL, is equal to 2. And then we're done. So still Pythagorean theorem, using that old stuff we've done before, now just plugging into our formula with our given information. Our next rule of this section states that when you have two tangents that meet at a point outside the circle, so that's important when they're outside the circle, then the tangents have to be equal lengths. So here we have two tangents. We have HR is one tangent and we have MR is the other. That means because they both meet at point R, HR and MR have to be congruent lengths. So this would be handy if I gave you something on your equation. For example, 5x plus 8 was HR and 2x minus 12 was MR. If I asked you to solve for x, then all you'd have to do is set those two equations equal to each other and solve. So I would subtract 2x over to the other side and then subtract 8, which would get us negative 20, and then we could divide by 3, which would get us negative 20 thirds. And obviously, you want to make sure that your answer is realistic to the problem. I just made this one up, so negative 20 thirds would not be a great solution for x, but in most problems, they'll work out nicely. Okay. And our last rule kind of uses the same rule we were just talking about, but uses it in a different way. So here we've got a circle that is inside of a triangle, and we want to solve for x and find the perimeter of the triangle. And this is all formed, the triangle is formed by different sized tangents. And remember, we just said in the last slide, when tangents meet at a point, then they end up having to be congruent. So finding x should be really quick because we know that this tangent from here to here has to be the same length as this tangent. So we could say right away that x has to be equal to 5. So there's part one of our problem, okay? And then we want to find the perimeter. And to find the perimeter, that means we add up all the side lengths of the triangle. So we already know one side length is 18. They gave us that, so we're gonna have 18 plus, we need to know the other length given to us. Let me choose a different color. So we need to know this entire length here, and we know 5 was the x, so 5 plus 10 gets us 15, so that's the entire length of the right side of the triangle. And then lastly, we need to figure out this last side length. And the problem is we only know a piece of it. We know the green part is 5, but we don't know what this tangent length is. So to find that measurement, we might have to fill in some information. And this kind of just means you have to go around the tangents. So we know that this tangent here was 10, which means this tangent is also 10. So I'm just gonna kind of fill in what I know. If I know the entire length of the top is 18, and I know this piece is 10, if I subtract those, I get that this tangent length is 8. Okay, and now we know that my two blue tangents have to be the same length, which means that this tangent here is also 8. So notice how I just did some addition and subtraction to move around my triangle, and now I can find my whole length here for the third side. If I add 8 plus 5, I get this length is 13. So now I can add that to my perimeter. So 13 plus 15 plus 18 gets us a perimeter of 46. And we're done. Not a lot of calculation in this type of example, but it's important to know that all your different tangents are going to be equal to each other if they connect at a point. So if you have any questions about this example or where I'm getting my numbers, let me know. I know the picture is marked on a lot, so hopefully you followed as I worked through this problem. Let me know if you have any questions, but that's it for today's section.